All right, let's jump right in. Today, we're going to talk about one of the most powerful, but actually super simple ideas in all of programming. It's the engine that lets computers do tedious, boring tasks for us automatically. And it's called the loop.
So here's our game plan for today. First, we're going to look at why we even need loops by starting with a simple repetitive problem. Then, we'll introduce the elegant solution, the loop itself. We'll peek under the hood to see how it thinks, explore just how powerful it is, and then we'll even cover a super common mistake that trips everyone up at first. And finally, we'll land on the absolute best way to think about this whole concept.
So, why do we need loops in the first place? I mean, what's the big deal? Well, let's ground this in a really simple, everyday task to see the kind of problem they were born to solve.
Okay, imagine we've got a recipe for a peanut butter and banana sandwich, and we've stored the steps in a list. If we want our program to display this recipe, we have to do it manually. You have to write a line of code for the first step, then another for the second, and another for the third. Each step needs its very own instruction.
Okay, but what happens if we decide our masterpiece needs a little something extra? Let's say we update our list and add a fourth step. Now what does that do to our program?
Yep, you guessed it. We have to go back into the code and physically add another line just for that new step. Think about it. Every single time the recipe changes, our code has to change too. This isn't just annoying. It makes our code really fragile and easy to break. It's just not a smart way to work.
Thankfully, there is a much, much better way to handle this. A cleaner, more powerful way to deal with repetition.
And here it is, side by side. On the left, you've got our clunky, manual way that has to get longer every time we add a step. But on the right, that compact little block of code is a for loop. It does the exact same thing, but here's the magic. It doesn't care if there are 3 steps, 4 steps, or 400 steps. You never have to change the code.
So how in the world does that little piece of code manage to be so smart? Well, it's not actually magic. It's just a very clear, repeatable logic that it follows every single time. Let's break it down. You know, what's really cool is that pretty much any loop in any programming language you can think of is really just answering these 3 basic questions. 1, where do I begin? 2, when should I stop? And 3, how do I get from one step to the next? Now, the secret ingredient here is that little variable, I. Think of I as a counter or a bookmark. It starts at 0 because in the world of programming, we almost always start counting from 0. After the loop does its thing for the first item, I automatically goes up to 1, pointing to the next item, then 2, and so on, perfectly stepping through the list for us. Okay, so displaying a recipe is cool and all, but that is just the tip of the iceberg. Once you get this basic idea, you start to see that loops are the absolute workhorses of programming. They can do so much more. For instance, think about your online shopping cart. How does it know the total? Well, there's a loop running in the background. It goes through each price in your cart, one by one, adding it to a running total to give you that final sum. And it gets better. You can put little questions inside the loop. In this case, a loop is zipping through a list of temperatures. For each one, it asks a simple question. Is this number 32 or less? If the answer is yes, it bumps up a counter. By the end, we know there were exactly 5 freezing days, no manual counting required. They can even build brand new things for you. A loop can go through one list, say a bunch of product prices, do a little math on each one, like taking 25% off, and then build an entirely new list with all the sale prices. How cool is that? Now, this power is amazing, right? But with great power comes, well, a chance to make some classic mistakes. A tiny error in your loop setup can have some pretty big consequences. Let's look at one of the most common pitfalls. Okay, pop quiz time. We've got a list of the 8 planets, and since we start counting from 0, their positions, or indices, go from 0 up to 7. Now take a close look at the loop's stopping condition. There is a 1-character mistake in there that will crash the whole program. Can you spot it? And there it is. The sneaky little culprit is that equal sign. See, the list's length is 8, so that less than or equal to sign tells the loop to keep going until I equals 8. The problem? There's no item at position 8. The last one is at 7. This is a classic out-of-bounds error. It's like asking for the 9th planet when you know there are only 8. So to help all of us avoid that whole mess, programming languages came up with an even cleaner, more intuitive way to think about this whole process. This brings us to the ideal way to work with collections of things. It boils down to this simple, beautiful phrase. Instead of messing with counters and indices and worrying if you're going to go out of bounds, you just state what you want to do. For each item in my collection, do something with that item. We don't care about its position number, we just care about the thing itself. And the beauty of this is that it completely wipes out the possibility of that out-of-bounds error. You literally can't make that mistake this way because there's no counter for you to set up incorrectly. It just makes your code cleaner, safer, and lets you focus on what you want to do, not the boring mechanics of how to get there. And you can see how this simple idea just cleans everything up. It applies to everything we've talked about. For each planet, show me the planet. For each price, add it to my total. For each temp, check if it's freezing. It's direct, it's clear, and it's powerful.
So when you get right down to it, loops are all about automation. They are the fundamental building block for taking any boring, repetitive manual task and making it totally effortless. Which leaves us with one final thought. What's the first tedious thing in your life that you wish you could write a loop for?